Thomas, first, AI. There's a lot of buzz around it, obviously, and therefore a lot of confusion as well. A lot of interest get meshed into that confusion of course, everybody selling products and services. So could you, for us, clarify what truly qualifies as AI, and in what way is it different from general software or algorithms?
One of the things that has somehow created the current hype wave of AI, because we have been through many of these, and we are in one now, is large language models. So generative AI stuff like ChatGPT or Gemini or Claude, or there are many of these systems. And I just wanted to talk. I just wanted to illustrate a bit somehow an embedding of these kind of systems in a bigger robotic system. And now, I mean, in a webinar, it doesn't make a lot of sense to show a robot. So I'm not going to run it on a robot. I'm going to run the chatbot on my computer. But there are a few points here. So later I will talk a bit more about the specific definition of AI. I just wanted to start out with this demo to kind of give an illustration of what it could be, right? And these robots are somehow built for communication and for being social robots. And in a way, when we talk about AI, it's a lot about building a system that can kind of interact with the world in some way. So it has some kind of sensors. In this case, it has cameras and microphones and stuff like that. And then it can affect the environment with so-called actuators. So it can move its arm, or it can speak and stuff like that. And right now, there's a lot of talk about agentic AI, and somehow my research area is in multi-agent systems, and that has been around for a long time in AI, but it's somehow again becoming interesting because it can do some new stuff now. So this idea of AI being an agent, like a kind of autonomous entity that can somehow solve problems on its own. So that's also a very important point. And then, as you can see, if you look at the top here, so there's a lot of different things going on. There's something about perception, and there's something about speech to text, and there's many modules. And AI this is also very important in AI, that it's not just one thing. It's not one technique. Now we have language models, but we have a lot of other things as well going on. And often, if you want to build a completely autonomous system, you need to combine these in different ways. Okay, so let me try to do the demo. And so it's a chatbot, and it's just going to be a brief demo of some of the things it can do. And it also uses video to try to somehow detect what is going on in its surroundings. So, okay, so as you can see now, I hope can you see that it's detecting me as a person? Okay, is it shared? Yeah, good. Okay, so one of the things that is going on is that it detects.
That sounds like a pretty accurate description, Thomas. It seems like you're in an environment that encourages communication and sharing ideas. Is there something specific you wanted to discuss or share with me today?
I just want to check with my audience whether they can hear what you say. Did you hear what the chatbot said? Yeah, good.
It sounds like you have everything set up nicely for a clear audio experience. I'm glad to hear your audience can understand me well. If there's anything specific you'd like me to address or discuss, feel free to let me know.
Yeah, I guess people have tried chatbots like ChatGPT and Gemini, so they kind of know what this is about. But I mean, of course, when you can talk to a chatbot, it gives you some more opportunities. So maybe you can, let's see, yeah.
It seems like you're in a perfect setup for discussing AI and chatbots. It's great that people are exploring different technologies like ChatGPT and Gemini. It broadens the understanding of what these tools can do. If you or your audience have any questions about how I work compared to those other systems, feel free to ask.
Can you change to my voice? Hello, Thomas. I've changed my voice to match yours. How does it sound? Do you like this new tone for our conversation? Yeah, it sounds pretty much like me, I would say. Great. I'm glad the voice change works well for you. It sounds like you're in a space that's perfect for focusing and discussing ideas. If there's anything specific you'd like to talk about or share, just let me know. I'm all ears. Okay, maybe say what you just said, but in Danish instead. Can you do that? Som selvfølgelig. Det lyder som om, du befinder dig et sted, der er perfekt til at fokusere og diskutere idéer. Hvis der er noget specifikt, du gerne vil tage. Okay, let's stop. It's a lot of fun for but let's stop for now. Okay, I just wanted to say a few things here, right? So about what we are seeing and hearing. So this is a fairly advanced system because it also uses video and stuff like that, right? And it uses some advanced voice generation. And what is interesting is that it picks up on my voice and it learns my voice from very little information. It has never heard me speak Danish, and yet when it speaks Danish, it's like it's scary close to how I speak when I speak Danish, right? And of course, these kind of things make people think that, oh my God, now AI is taking over the world or whatever, right? We are very close to like human level AI, and of course in some aspects we are and have been for quite a while. But what is also really important to understand is that these systems are based on pattern recognition, right? And recognizing, for instance, the sound of a voice is a pattern recognition problem, right? So the difference between Stephane's voice and my voice is something about patterns, how we phrase different words. And this is one of the things that computers have become excellent at. And actually, it's also the basis for language models that we can talk a bit more about later. So this would be one example. But let's go back to the very beginning of all this, which is back in the 50s. So John McCarthy is the father of AI. He coined the term and he came up with the first definition. And he said that it's the science and engineering of making intelligent machines, especially intelligent computer programs. And I don't think anybody in AI will dispute McCarthy, not just because he's McCarthy, but also because the definition makes sense. But the problem here is that we actually don't really have a good definition of what intelligence is. So the definition is not super helpful, right? So in itself, this doesn't create a clear boundary between AI and other types of uses of computers. And one of the questions that Stephane asked is like, what is the difference between AI and like regular software? And then we could say, yeah, McCarthy would say, well, AI is intelligent, right? But then psychologists and neurologists would say, but what is intelligence? And so actually the honest answer here is that there is no clear boundary. Actually, and I will give you some examples later, but to illustrate that. But what I would say is that it's always inspired by natural intelligence, usually human intelligence, either because we create artificial neural networks, that's what you saw just before, that can perceive the world, that can identify things in an image or recognize voices, that kind of stuff, where we try to somehow mimic the fundamental processes in the human brain. So that's one way. Another way is if I were to build a driverless car or chess computer or something, I would somehow try to look a bit at what kind of thinking is it that goes through my head. I think about my next move, or I think about whether I should turn left or turn right, and then I try to build a computer that can kind of mimic it, right? So human intelligence is definitely at the core of this. It's always about getting inspired by human intelligence when we build these systems. But then we can still discuss whether something qualifies as AI. Is it intelligent enough? And I think a nice example here is like if we go back to Shaky the robot in the 60s. So that was a research project at Stanford Research Institute. They were, by the way, also the ones who ended up building Siri that was acquired by Apple. the chatbot. And they built this robot for pushing big colored boxes around. And they had a lot of ideas during that project, and one of them is what later became the core of Google Maps. And the question is, because in a way, sorry, I'm just playing around with I thought I had a pen here, but apparently not. So definitely people would. And in particular, at the time of Shaky the Robot, this was definitely considered AI. Actually, Shaky the Robot was on the cover of Time magazine, and was dubbed the first electronic person, right? So there was people definitely considered AI. And then Google Maps, by today's standards, I mean, even being based on the same idea and the same algorithms, I mean, maybe people would say, yeah, but it's just standard algorithms. What is AI about it, right? So it makes the distinction a bit unclear in this case. And actually then later, the same ideas again were used in the Amazon warehouses and are still, I mean, the same type of algorithms, the same type of fundamental ideas that go back to Shaky the Robot. And maybe we would be more willing again to accept that as AI. It's just to say that, okay, maybe we can talk about levels of AI in terms of how somehow advanced is the problem that these systems are solving, how complicated or unpredictable is the environment that they're supposed to work in. Of course, it's easier to build an Amazon robot than a driverless car, but there is no fixed, unfortunately, distinction between AI and non-AI. So yeah.
So then, Thomas, can you then explain different types of AI? Because here you talked about levels of sophistication and complexity, but are there at the basis of the technology different types of AI you can distinguish?
Right. Yeah. So that's a very good point, because if we look at what happens here with the Amazon robots, then this is completely different set of techniques than what we saw in the chatbot. Well, except when we run on the robot, it can also do something like the Amazon robots can do, and it can find its way from A to B. But still, the Amazon robots are built on a completely different set of techniques. And let me try to then illustrate that. So these techniques are paradigms, actually, because I mean those are sets of techniques, so we call them paradigms. There are two main paradigms in AI. So the symbolic paradigm and the subsymbolic paradigm. So what does it mean? Okay, so think in terms of rules when you think symbolic. So you have some rules and you do reasoning based on those rules, right? So maybe it could be something like with the Amazon robots, you need to get a particular shelf with a particular item to a particular customer. It could also like planning your dinner or whatever, right? And you know when the supermarket is open, you know some recipes, and you try to somehow search for a plan given these things. And in subsymbolic AI, this is where we instead try to mimic some of the fundamental processes of the human brain. So it's more bottom up. It's more starting with the simplest mechanisms that we know of in the human brain. And what are those simplest mechanisms? If you think about different levels of reasoning, and also think about humans versus animals, right? So most animals have eyes and can perceive actually quite well. Many really well. Like there was a study some years ago where they trained pigeons to detect breast cancer, and they did extremely well, like 90% accuracy. And they were simply trained on scanned images of tissue, right? So mammography. And it's of course because part of their brain is a big and quite advanced perception system, which is based on a natural neural network, but we can build artificial neural networks that does something along the same lines. if you look at what we have here, right? So we are recognizing objects. It's the same system that I used before in my demo. You can see that all these items have some numbers after them. That's because when we go outside the world of rules and move into the world of patterns, then we are never really certain about anything, right? It's like we see something, or it appears to be something, we're never quite certain. The thing is here that you don't learn what the difference between a car and a truck by any set of rules. You learn it from seeing cars and seeing trucks, and your parents or whatever telling you, oh, but this is not a car, this is a truck. And then you kind of pick up on those patterns. And this is how we also train these algorithms. We give them lots of video or pictures, and we tell them what is what, and then after some time they start to pick up. Right, but it's statistics, right? So you're never fully sure. So when it says truck 0.57, it means that the neural network thinks there's a 57% probability that it's a truck. I mean, it's not a real probability, but we can interpret it that way. And yeah, so sometimes some interesting stuff goes on here. We can return to that a bit later, but it makes some like interesting mistakes. Whoops, like here. So all of a sudden there's a skateboard, right? And these two guys are doing parkour. So where did the skateboard come from? And also, if we move a bit further, oops, it's gone and it comes back. Now it's a bird. Oops. For a short while, it predicts it to be a bird. And this is about context, right? That you somehow look at a pattern in context. And when these persons are flying in the air, they look as if they could have been on skateboards, right? And now you have something in the air that could look a bit like a bird with wings. So the power of these systems in subsymbolic AI, in particular neural networks, the power of them is that they can learn to recognize patterns and generalize from the examples. Of course, the weakness is that you can never be fully guaranteed that they will come up with the right classification. And this is also what we see with something like ChatGPT and Gemini when they don't come up necessarily with the correct answers, because they are recognizing patterns and they are trying the best they can based on the patterns they've seen. So this is the show. I mean, we don't have much time today. This is like I could give a several years course on all of this stuff, right? So now we're just scratching the surface of this stuff. And talking about scratching the surface, this slide is a bit overwhelming, but you don't really need to understand the details. It's just to again emphasize this fact that we actually do have many different techniques in AI, and we have to somehow recall that. And when we look at something like the Amazon robots, we have a lot of stuff going on up here with search techniques and automated planning. And when we look at the chatbot, we have a lot of stuff going on with large language models, which is part of deep learning, which is part of neural networks, which is part of machine learning. And again, in a very short introduction as this, we cannot go into the details. It's just to somehow, I think it's a bit important to recall that despite all the talk at the moment being about large language models, then there are more AI types of AI in the world, and sometimes other types of AI are the better ones for whatever problem you might have. So yeah.
Is it fair to say then that all the subsymbolic is much harder to explain? Like to explain the results, because as you said, it was kind of pattern recognition, statistically based outcomes.
Yeah. I think it's fair to say that this is how it will be by default, because if you're in the top half in the I also even write that explicit models explainable, right? And it's okay. So let's say that one of the Amazon robots was misbehaving and it chose a strange route or something. I actually have some nice videos about two Amazon robots moving back and forth like this because one wants to go left and the other one wants to go right, and then they both try to go one step in one direction to pass the other one, but the other one does the same, and then you have this kind of path walk dance between them, and that never finishes, right? Because they're stupid. So but the thing is with these kind of systems, they're very easy to inspect. It's also what people use for like satellite control and things where you need to be absolutely certain that when you ship it off, it's going to work, right? And it's going to somehow you can verify that it has the properties you want it to have. So these Amazon robots, the algorithm that it runs is kind of, it's verified that it behaves as expected, and if something unexpected happens with one of the versions of the algorithm, then you will be able to look at the output and understand like what is going on. Mm-hmm. But in a way, if you talk about perception, right? I look outside the window and I seem to be seeing Santa Claus flying by, right? And then I look again and then I see it's a bird. And then you ask me, okay, but why did you say it was Santa Claus? I can only say, well, it looked like Santa Claus, right? There was some red and some white stuff or whatever, right?
Or similar subjectivity, yeah.
Yeah. So I mean, there are also many of these tasks where if you ask a human to do them, that the human would also have a hard time explaining them. But of course, there are many things that we now try to do with some subsymbolic techniques like large language models, like chatbots, like I just showed you, right? Where we would like to have explainability, like in the real sense, that you somehow, a chatbot says something stupid and you say, okay, why on earth did you say something that stupid, right? And at the moment, we don't have good answers for that, right? We are trying to come up with techniques to explain, but the problem is that for instance, large language models like ChatGPT, they have something like 1,000 billion parameters. What does that mean? It means 1,000 billion neuron connections, and they are all individually adjusted when you train it. So you train it on the entire internet, and you have this like insanely large computer with 1,000 billion variables, like numbers. And then you want to understand, when you get a particular answer, which number or which combination of numbers were responsible for giving this particular answer. That's not trivial at all. And this is also why, I mean, it's discussed a lot in research, but also in regulation, right? If you look at the AI Act and the entire discussion that led up to that, and there was this high-level expert group that discussed ethics and all these kind of things are kind of coming from the fact that we made all this subsymbolic stuff work very well, in principle, at least, right? But somehow, when you have a system that is trained on data and it learns itself to find its own patterns, then it's really hard to know exactly what kind of patterns were found. And of course, for instance, in my commune in Frederiksberg, when they start to use these techniques to decide which citizens should be permitted cleaning assistance or something, then it starts to be a bit controversial because nobody has any idea like what is then behind that decision, because it's not really a decision. It's not a reflective decision. It's some kind of assessment based on association with existing like data, like historic data, right?
So shifting gear precisely with innovation, then, where do you see AI making a big impact of innovation, and do you have some examples to inspire us as to what we could do with it?
I think in the long term, we can also return to this point later, right? But I think in the long term, a lot of innovation will be in getting these two different worlds to talk together, right? So probably many of the people in the audience here know Kahneman's book Thinking Fast and Slow, that has kind of conquered the world, right? And it's a bit similar here with the symbolic and subsymbolic stuff, right? That we have some techniques for reflective reasoning, for slow thinking, and we have the others, the subsymbolic for the fast associative thinking, right? But in the human brain, these are very well integrated, right? And things can flow from one to the other. This we don't know exactly how to do in AI, so it's a big challenge, right? But of course, it's also a big research challenge that has to be solved first. But otherwise, I would say, of course, a lot of stuff is happening these days in large language models like ChatGPT, right? And this is now, yeah, so unfortunately, this is the newest stuff I had because it's based on the Artificial Intelligence Index report. So Stanford University is doing this 100-year study on AI. It's super interesting, and they have this 500-page report every year that it's very like valuable stuff. Of course, they take also from other sources. So now this is already a couple of years old, but I think it's still an interesting chart to look at in terms of what people are doing and where things are moving, right? So at the x-axis, we have different, well, either techniques, because some of this is techniques and some of it is like reinforcement learning is technique, and computer vision, well, it's kind of technique, but it's also for a particular purpose, namely to observe things, right? And if we see where things are somehow having a lot of traction, then there's a lot of stuff on robotics, process automation, which is not in the financial services, which is not necessarily very advanced. But what we're seeing now is also that a lot of stuff is happening where people use language models or may try to have language models help with this, right? So help will, in principle, maybe mundane tasks. I mean, not too difficult tasks, but where you have an AI that can learn to do this task, right? So not only learn to recognize things in a picture, but actually do, I don't know, transactions, receive, send emails, communicate with other agents or systems, that kind of stuff. Then you can see there's a lot here on the natural language text understanding, which is not so surprising because, again, we got ChatGPT. Everybody wants to use it and get something out of it, right? And people are using it to, I guess, in many companies that I've talked to, it's still used kind of informally, or I mean, people use it in there somehow to help, I don't know, write a text or summarize a text or come up with some ideas for an advertisement campaign or something, right? But it's more on that level, like a personal assistant. Like instead of asking your colleague, you ask ChatGPT. So I see many more examples of that than it's really embedded in a product, say, right? So, but I think there's still a lot to be gained there. Definitely. So because we only had ChatGPT for a couple of years, and I still think there's a huge potential. Also, these language models keep getting better. Yeah, I mean,
one thing that's striking, Thomas, on that table to me is the contrast between the RPA, robotic process automation, that's pretty high, especially financial services, and then the physical robotics, that's actually very low.
Yes, that in the middle. Right, and that's interesting, but yeah, okay, so that maybe also relates to a point I can bring up later, right? But somehow, yeah, I think it's a bit about low-hanging fruit, right? That physical robots are difficult in many ways, and sometimes people have been doing things manually like copying things from one application to another application that could not directly communicate or something, right? Uh, like dragging things on the screen, or I mean, stupid things, right? That have been costing so many hours. Or for instance, there was one. So that's Familienratshus. I don't know what it is in English, but they spent several man years on simply crossing out personal data in documents, like with a tush. And then they found out that they could use AI to recognize that you scan the papers, you recognize what is personal data, and you get rid of it, right? So sometimes it's stuff like that people do. And with physical robots, why is it hard? Well, so it's hard. One of the things is that a physical robot is very often in an unpredictable environment. Okay, so what did Amazon do? They tried to make the environment super predictable. How? Well, they got rid of all the human beings, first of all. There are no human beings allowed where these robots drive. Then also, if I stop the video, if you can see down here, so there's a QR code, right? So there's these barcodes that the robots are navigating between. And also they can only do very few things. They can turn left, turn right, or drive forward, or activate the lift. So in order to make this problem solvable, they had to reduce the complexity enormously. So it's essentially like a giant chess game or something where you're moving the pieces around, and that's all, right? And that's way simpler than if we talk about a driverless car or humanoid robot that can walk around and do anything, right? And talking about humanoid robots, then I have an example here. So and this is something that this is a kind of commercial. So I would I would wait personally until I had that robot in my lab and then I can see what it can really do, right? Because yeah, you never know, right? But I think it's interesting because this at least points into the future, right? Stephane, you also asked about innovation and where are things moving and where is innovation happening. And this is maybe not next year. I mean, despite what people say, I would say this is a bit further down the line, right? But of course, there's a huge potential in humanoid robots exactly because they're humanoid and they can actually move. Then the new version has legs. So, I mean, in principle, they can move wherever a human can move and they can do whatever a human can do, right? And you just saw the chatbot I discussed with that, right? That can change language, that can adopt my voice. So of course, putting that kind of technique into a robot has a lot of potential, and this is definitely one of the somehow directions that things are taking currently. What is less clear is how difficult this is. I mean, how long it will take before this is like what we see in all factories, for instance, right?
Right, because the grappling in particular is extremely complex to model and implement. And so I was thinking precisely continuing on that note, if we can take a step back and look at the general misconception we may have about AI, or maybe some general ways of thinking what is good for AI as a natural application for AI and what may be more difficult, maybe.
Right, yeah, okay, so let's see. Right, okay. So I would say it's not that easy. The question is not that easy, right? And I guess it's also why you can get a lot of people attending a webinar like this, right? Because if it was someone who had developed a truck and asked what can you do with a truck, and you can put stuff into it and you can move it from A to B, right? You wouldn't want to attend a webinar on that, right? Because it's pretty obvious. So you just decide what to do with it, right? So this is that kind of it's notoriously difficult. But what I would say, I think it makes, and it's a moving target, right? It changes all the time, because also like having a dialogue, for instance, that would have with a robot, that would have been considered one of the really difficult things some years ago, and now it's not difficult. Well, no, maybe it's difficult to tame it, right? It's difficult to use it to build a chatbot in a company and guarantee that the chatbot only like gives the replies that you want it to give. But of course things are changing, right? So instead of trying to make a very clear somehow list, I would try to somehow give some general comments about it, right? Because I think you also mentioned this about robotics process automation that are, as I said, often very simple things. I also mentioned that in the Amazon warehouses, they try to make the warehouses robot friendly by simplifying, right? So in a way, the best way to try to understand if something is automatable or you can augment your possibilities with AI, I would start asking how well defined the problem is, and how somehow predictable the environment is. So playing chess is something super well defined in a super predictable environment because you have very few rules in chess. Driverless cars, well, yeah, there are rules in traffic, but it's way less easy I mean, there are way more rules, and they are not as mathematically precise. And then if we wanted to build one of these humanoid robots, then it's super difficult because you're kind of expecting it to behave in the right way in many situations, right? And maybe also situations it hasn't been in before, and that makes it very hard. So either it becomes very hard, or it becomes so I wouldn't necessarily say that it's impossible to have AI systems that don't solve well-defined problems in very predictable environments, because I would say that something like large language models can answer any question you might have, essentially, right? So that's not a well-defined problem. It's not very predictable, but also the answer you get is not very predictable. So, and I don't know, I mean, it depends then on what kind of problem or what kind of company are you in. And I mean, so I've been interested in robots and looking at manufacturing businesses and that kind of stuff, right? And often there you have a very high demands on quality, right? If you want to use AI, it's because you want to check that something has the right quality or is positioned exactly correctly or something like that, right? You don't want anything that is unpredictable, and that kind of drives you in the direction of making sure that your problems are super well defined and predictable. So I would always say that if you're kind of starting your AI journey, I mean, some companies are already super advanced and some are not, right? But if you're kind of starting your AI journey, then I would start out looking for the chess problems in your company, right? And they're not easy for humans. It could be like pathfinding, logistics. I mean, there's a lot of these that are very well defined. You have rules, or scheduling, whatever, right? So yeah.
So Thomas, for the sake of time, I was wondering whether you could speak a bit, continuing on that vein of where you start as a company, and you have that, I think, a couple slides further. If you go to maybe 12.
Yeah, good that you you know my slides because you can browse back and forth, and I'm sharing my full screen. So yeah, good, thanks. Right. So what I just said was this about the characteristics, right? That somehow AI, in either you're looking at something really well-defined, and then it's possible to make AI work. If you're looking at something less well-defined, where even as a human you might not be able to set up exact rules for the problem you want to solve, you can still use AI, but then you have to live with potential lack of robustness, to potential lack of explainability. And related to that, one of the things to be aware of is the distance from the cool demo to a robust product. And that's also related to what I said before about I make my decision when I have the robot in my lab. because cool demos is something, well, the point about AI exactly with the well-definedness is that often you can actually make a cool demo quite fast, but scaling up to something that is robust and never make mistakes can be exceptionally hard. And I really like this example that it was actually already in 1994 that a driverless car drove 1,000 kilometers in public roads in France. So like way before most people thought about driverless cars. And then still yet it's not completely solved, right? and for instance, in 2016 and 19, there were these Tesla crashes where a Tesla would look at something like this and think that it's a road sign because, well, it's a big rectangular surface with some text on, so what else can it be, right? It's like what I showed you before, where it recognizes my cell phone and me as a person. And as I said, I mean, you're never 100% certain, right? Then I would say, okay, so these are kind of things to be aware of, because I have also seen a lot of projects that ended up in nothing, where people were too optimistic, right? So I'm not trying to say that one should not do AI. On the contrary, but of course you should throw your resources at what has the somehow largest potential. And then, based on all I said, I think it's quite clear that somehow it's not intuitively obvious for a human being where AI would be good, because often AI is good at very different things than humans. So you need some minimal expertise. I'm not saying that everybody has to know like the details of how a neuron is updated in a neural network, but somehow you need some kind of expertise. And also, even if you buy tools from the outside in your company, you need to somehow know what they are trying to sell you and whether it's kind of realistic, because sometimes you also get offers where they say, well, but we cannot give any guarantees about how well it will work, because that's not how machine learning works. So we just give us your data and then we'll try our best, right? So and then someone has to be able to somehow cut through all that and say, okay, is this realistic? Are we solving a relevant problem here? Is it possible with the data we have? Will it be robust enough, etc.? So that requires some people who know something, right? And it can either be by like educating. If you don't have that expertise already, then education, like, well, continuing education, for instance, or hirings. Of course. People who are experts on these things are in high demand, but the places where I've seen greatest successes where they have a fairly big team of experts that can build up things from themselves inside the company, right?
But can you say a word about the privacy, because of course that's an issue, confidentiality of information in using those systems.
Yeah. So that's a good point, right? Because it also depends on what are you doing? Are you trying to somehow are you trying to build a system from scratch, essentially, which is possible, right? Let's say you need to do some quality inspections on a product, and then you decide to use a neural network to film the product from different angles and then decide. So it detects whether there's some irregularities, right? That is something you can build from scratch. And even now with ChatGPT, you don't even need to be a very skilled programmer. You can actually make ChatGPT help you write the code, right? But of course, if you want to employ large-scale existing systems like language models, ChatGPT. Of course, you need to kind of worry about that. You need to worry about privacy. You need to worry about what happens to your data, and there are kind of two possible answers here, right? So one is trying to get a deal with a provider, a language model provider, who gives guarantees. So I'm now not expert on legal stuff and how trustworthy things are in that respect. But for instance, ChatGPT, they have an enterprise edition with all sorts of guarantees about privacy, right? And I know the competitors have something similar. But of course, you still send your data to the US. And maybe we don't even want that at all, right? And then you can try to look at the open source alternatives. This is always something that is growing, and somehow more or less by definition, what is currently state of the art in whatever area of AI in a couple of years, it will be open source, and it will be much more easy to access for everybody. That has so far always been the case. Of course, here we can say, okay, but there's something about the size of the computer that you need and the training data. And I think Bloom is a good example because it's fairly large. So it has 176 billion parameters. So it's not quite the newest version of ChatGPT, but it's like the previous version. Of course, that doesn't run on my laptop, but it runs on a 1 million Danish kroner computer, right, or something like that. So there are definitely possibilities also of simply disconnecting entirely from the world and then run your own language model. And an advantage is, of course, that you can also keep training it on your own data, so you can specialize it for your own particular usage.
Okay, and Thomas, just again, because we have only 5 minutes left, but I would really like to hear you about AGI. You know, where we are going now, the famous crystal ball, and you know, how do you think about AGI? There's been a talk for a long time where it was always far into the future, and now at least some people say it's very close. So I'd like to hear you about it.
Yeah, but let me make it short. I don't agree, or I don't think. I don't know, right? I cannot know, but I don't think, right? And just to again make it short, let me only focus on this top. This top quote here. So this is from AAAI, is the North American AI Society, like one of the most respected organizations within AI. And they made a report very recently, it's partly based on a survey among AI researchers. So, I mean, if anybody knows, they should be the one who knows. and the majority says that, well, we don't think that the current techniques can scale up to something like human level intelligence. So what does it mean, the current techniques? Right? It means that new ideas have to come into the picture. Like what I said about deeper integrations of symbolic and subsymbolic AI. And then, of course, Stephane, you will say, okay, but when will we have those? And then I will say, well, how do I know? because I mean, this is research, right? We don't know. And also, like with language models, I followed the path. I saw GPT-1, GPT-2, GPT-3, GPT-3.5. I was not too surprised when ChatGPT came around because I had followed the development, right? But it was still a relatively short time frame that changed a lot in terms of what we can do with AI. So it's really impossible to say here, right? But I think there's no particular reason to believe that it should be within 5 years or something. I simply don't see that. Because if it's true that we need new techniques, we don't know if it will take 5 years or 100 years, right?
And then final question about the safety, because that's also another hot topic on how safe do we think AI is. And you have some of the top experts, Jan LeCun and Joshua Benjo and Jeffrey Hinton, who are all at the top of their game, who have completely different opinions about it. So I'm just curious to hear what you think.
And what does AI safety mean in this case? Like whether it will take over the world or?
Yeah, you have like Suleimani from Microsoft who talks about containing the technology before it becomes potentially dangerous in its applications. And like Claude, Anthropic, they have their responsible scaling policy, which is where they see some models, for example, scaffolding or sandbagging their capabilities, lying about what they can do.
Yeah. Again, also a really, really difficult question. I think one thing that's super interesting here is that when I think it was GPT-2, when OpenAI had made GPT-2, they didn't release the full model. So we are back at something like 1 million parameters or something. Like it was, it's so ancient by today's standards. But they didn't want to release the full version because they were afraid it could be used to produce fake news and that kind of stuff, right? And then soon after they release it and they make one that is bigger and even bigger, and now they're happy. I think I think nobody really knows, right? And that's why people are so wild. That's why people so wildly disagree. And I think also, if you are an expert on AI from a technical perspective, it doesn't mean that you're necessarily an expert on how AI interacts with society, right? So I think that I'm not sure those are the people we should necessarily ask. In the same way as I don't think Sam Altman is the one we should ask about AGI. Why would he know? I mean, he's not an AI researcher, right? But who should we ask then? Maybe philosophers, but I'm also not sure, right? I think from my perspective, when we look at what happens now with language models, one thing that is very important, I think, is that they are not having independent goals. They are not somehow, they're not breaking out of anything. They're not somehow coming up with plans for taking over the world or whatever. I mean, they're just trying to predict the next word in a sentence. That can still go bad. Why? Well, because I mean, I know people who start to use it like personal psychologist or giving life advice and stuff like that, right? And that kind of life advice could be bad for you, right? But this is a human error. It's not the machines that somehow start to take over the world one way or the other. It's about how we decide to use those systems. And I guess I guess we need another hour for that, right? Because it's sometimes that discussions is also maybe sometimes a bit confused, I would say, right? That it's not clear what we are talking about when we talk about the scary part of AI, right? Is it about the machines becoming too smart, or humans using it in a stupid way, for instance? Yeah.
Thank you very much, and we are out of time. So
Teresa, back to you. I just want to say thank you so much, Thomas and Stephane, for joining this webinar, and I hope that everyone who joined got some answers, even though we just scratched the surface in the world of AI, as Thomas mentioned earlier. I think we need another webinar or maybe another lecture. If you are interested in more information about the CEL program, the Corporate Entrepreneur Leadership Program, or in lectures about AI, please reach out to me, and I'll be happy to support you in any way. So thank you, big thank you to Thomas and Stephane. It was a great pleasure.
I just wanted to say I can stay a few minutes if some people have questions, because now we kind of promised it. I don't know. I mean, if you can let the meeting stay open. I actually do have another meeting, but I can.
And somebody had actually raised their hand. So if that person is still on the webinar, maybe they will come back to ask the question.
Yeah.
So it was Serkan.
That was me, actually. Thanks a
Yes.
lot. Thank you for your time. You just mentioned about, slightly mentioned about how AI is going to be used in society, how AI is going to interact with society. I just want you to kind of elaborate more on that topic. It's a really broad question, I know that, but I just want to ask this. Thank you.
Yeah. Right. So I think that somehow, until not so long ago, AI was kind of confined to be more passive tools that were only solving particular problems, right? So I think when we get something like large language models, something happens not because they're proactive, as I said, they're not really proactive, right? But in the way that we start interact with AI systems in more like we would interact with other humans, right? And we don't really know how this will impact us, right? We don't really know what it will do to our brains and our society. It's a bit like with social media. We had some ideas about, it's really cool with social media, it's really cool with smartphones, and now we talk about trying to reduce it a bit and not spending too much time in front of a screen, right? So there's something there about what AI does to the way that we work, right? So it has these obvious benefits. I'm using ChatGPT all the time to help me with various tasks. I love it, right? So but I also see that when it gets into the personal sphere, it's maybe a bit more tricky. And I do research on social intelligence, and it doesn't have like anything that is even remotely comparable to human level social intelligence. So of course it can kind of end up screwing up things that we have something that we believe matches human interaction, but it doesn't really. I'm sorry if it's a vague answer, but maybe, yeah.
No,
I don't know if it's
great, because the question itself was also actually a bit general.
Yeah, so I matched the generality of the question, but I hope it made sense at least. Yeah,
it does. Thanks a lot. And I think it's really interesting to think about the way we interact with the different gadgets as well, as a computer screen, for instance, how we kind of thought about it for 50 years ago and how we do it actually today. So it's a quite interesting topic with the AI. Thank you for that.
Yeah. And exactly right, because also the part of the point with the demo was that, well, most of people are still using ChatGPT like as a text interface, right? But also recently they added the voice interface, right? And we also added a robotic like a physical robot, right? So and then when it can actually do a lot of tasks and interact with us in many ways, it's starting to, it's just a very different world, because we used to have to bend our minds to get computers do what we wanted, because computers think in a very squarish way. And now we are in a situation where the interface to whatever the computer can do is much easier to handle, and the distance is much shorter, right? So computers have been able to do many things for many years, but the interface to those capabilities have become far more accessible, I would say.
Yes, I think other people has a question, but I have a small question as well. You just mentioned about this distance, right? The distance is still something you can measure, because the distance between your fingers and the volume and etc. How about there is no distance anymore at some point? How that would look like?
So like AGI, like what Stephane talked about, is that what you're saying?
Yeah, maybe.
Yeah, no, I don't know. Yeah.
Thanks a
lot.
lot.
Thomas, there was just another question around the same lines, maybe a bit, which was, what is the next big leap in AI that would dramatically change its usability? Talking about interface and what it can do.
Yeah. No, I still think it's about getting this interaction between symbolic and subsymbolic techniques right? And they talk about large reasoning models, and there was this model called O1 or Strawberry that OpenAI made in the early autumn. And there was also a lot of hype around that, and where people say, "Oh my God, now we have AGI," right? And that was actually an attempt of going in that direction. And then, well, you spend a bit more time and you find out, okay, it still has some weaknesses. But there's a lot of people working very hard on this now. You want systems that you can interact with them in natural language like you can with ChatGPT, for instance, but they can also make plans, and they can also do some kind of social reasoning, the kind of stuff I do. So one system where this is all somehow, it's all inside. I don't know, it's difficult to say, but it's better integrated than now, right? So maybe an example, if I may, because I mean, you can just leave, of course, when you're when you're out of time. But in driverless cars, right? So there's a decision system that's based on rules, symbolic AI, and there's a perception systems for instance, in a Tesla, it's a camera, right? Those systems are completely separate. So the decision system waits for the perception system to somehow tell the decision system what it sees. And this is one of the ways that it can go awfully wrong. There was also a woman killed by an Uber Volvo, driverless Volvo at some point, where the perception system couldn't exactly, it was a bit dark, and she was going with her bike, and it couldn't make up its mind whether she was a pedestrian or she was a vehicle, or maybe she was something else. And then this neural network keeps changing its mind, and the decision system is just waiting for it to make up its mind. And then she's killed, right? And it's like, what? I mean, a human would never do that, right? I mean, I'm uncertain about what I'm seeing, fine, but I'm seeing something. I better, like, even with the little evidence I have, I need to make up my mind and do something, right? And this is a mystery, though, right? It's a bit of a mystery, I would say, in human intelligence, like how we can do that. How also do we get from patterns to words, like images to words, and from words to thinking logically and coming up with plans? And this is, if it's solved, it's a huge leap, I would say. If it's only solved a little bit, it would still be a huge leap. But I think for me, this is the remaining holy grail in AI. Yeah, and how if is it within reach? I don't know. Yeah.
Great point to end the conversation, Thomas.
Fantastic. Is
Thank
there
you very
more
much.
messages? Yes, thank you. Everyone says thank you. So